the solution to WEX 153. Okay, so for part A, the formula for the total value of the money flow, the formula there is integral 0 to big T f of little t d little t. And on this particular exercise, that means integral 0 to 20, and then that, so 2400 multiply exponential of 0.03 t dt. So that 2400 just hangs out, so that's 2400, and then exponential of 0.03 t, and then now divided by 0.03. That's one of the anti-differentiation tricks you're supposed to memorize. So 0 to 20 there, and then now I'll divide that constant. 2400 divided by 0.03. That's 80,000. So that'd be 80,000, and then exponential 0.03 t from 0 to 20. So that'd be 80,000. Leave that factored out, and then plugging in 20, that's exponential of 0.6, and then plugging in 0, that's the exponential of 0, which is 1. So that's the exact answer. And then as an approximation, that would be 80,000, and then exponential of 0.6, subtract 1. So to the nearest cent anyway, that would be 65,769, and then 0.50. For B, and again, from here to here, in case you're not sure what was used, is that from here to here, I use that the antiderivative of the exponential of kt dt is the exponential of kt divided by k plus a constant. And this works for any k that's not 0 and constant. So in this case, I did it with k is 0.03. Alright, so the present value of the money flow, this again is a formula that you're supposed to memorize. So the formula is integral 0 to big T f of little t exponential negative RT, that's R little t, dt. So that's a formula that you must memorize. On this particular exercise, that's integral 0 to 20. F of t is 2400 exponential of 0.03 t. And then now, so that's f of t. And then now we need to multiply by exponential of negative r. Well, r is 5%, so that's 0.05 t, then dt. All right. So now the next step, many students messed up. Specifically, what you must know is that the rules of exponents, and in particular exponentials, say that when you have the exponential of a multiplied by the exponential of b, which is the kind of thing that we have there, you can combine this into a single exponential as an exponential of a plus b. So as a result, this is integral 0 to 20, 2400, and then now I'll just write those as a single exponent. So that would be 0.03 t, and then subtract 0.05 t dt, and then carrying out that subtraction. So integral 0 to 20, 2400, exponential of negative 0.02 t dt. Okay, so that's what we want to evaluate. So that would be 2400 exponential of negative 0.02 t divided by negative 0.02, and then this boundary evaluated from 0 to 20. Alright, so then I'll divide that. So dividing 2400 by 0.02 gives you 120,000. So then now exponential of negative 0.02 t, and now the same trick as usual is that negative, instead of keeping the negative around, I'll spend it and change the order of the boundary evaluation from to swap it. That is to say that remember that if you have something that looks like this, negative f of t from a to b, like that, that's equal to just regular f of t, but now you swap the order of the boundary evaluation. So that's what I did there. So continuing, this would be 120,000, and then multiplied by, well, when you plug in 0, that's the exponential of 0, so that'd be 1, and then subtract, plugging in 20, exponential of negative 0.4. So that's like the exact answer. And then to the nearest cent, I suppose, the answer would be be 39,561.59 to the nearest cent. Finally, C, the future value of the money flow. Another formula you're supposed to memorize. The formula is exponential of r big T times integral 0 to big T, f of little t times exponential negative r little t dt. Now that looks, of all the formulas so far, that one looks like the worst. But in fact, this is just saying it's exponential of r big T and then multiplied by the present value of the money flow, which is what we calculated right there. So as a result, the answer is exponential of 0.05, because that's r, and then multiplied by 20, and then multiplied by that number there. So 120,000 times 1 minus exponential of negative 0.4. So that's the exact answer. And then to the nearest cent, so 0.05 times 20 is just exactly 1. So then no wait, is that right? Yeah. Okay, so then times 3. Yeah, okay. So then the exact answer would be 1. How many numbers is that? 107,539. 0.56. So the I'm gonna indicate the numerical answers just so it's easy for you to spot them, but do understand that it is your work that's being graded in this exercise, just like all others, and without the proper work, you will not receive credit.